Hello, hello, everybody. Can you hear me? Everything okay? You can hear me loud and clear? No interference? Okay, so let's start it. Welcome. It's the first time here in such a conference, and it's the first time that I'm presenting for such an audience about some awesome things that we do at Philips. Therefore, my name is Roberto Marcu. I'm a senior system engineer at Philips Image-Guided Therapy Systems, and today I will give you a very brief overview about how we develop medical-grade software for our X-ray systems. We at Philips IGT, we create and develop X-ray systems used for minimally invasive cardiovascular procedures, such as our flex arm system. What you can see here is that the doctors prepare the patient. They introduce catheters and everything that they need. After the patient is prepared, they move the system into position so that you can acquire X-ray images. And after the X-ray images are acquired, they move the detector to the right place so they can see the region of interest that they want to radiate. What you can see here is reconstruction of an artery with contrast injection. So you can see pictures like subtracted and different processed images. You can also rebuild the vessel structure if you insert a contrast agent, and voila, you have here, for example, the reconstruction of your foot, the vascular tree. So this kind of X-ray systems we create. But what do you think that medical devices, medical industry, the aviation industry, and the car manufacturing industry has in common, software-wise? Well, that software is safe. It means that it comes with a guaranteed quality. It's safe to use, and it's reliable, because it comes from a regulated industry. A regulated industry means that regulatory bodies are watching over you, and that also you have to fulfill some standards. Every journey starts with a vision, and our vision at Philips is to have better treatment, better care for more people, and we want to achieve this in a safe manner. We want to achieve this with sustainable manner, with latest innovation, and with patient safety at the core of everything we do. Patient safety is something mandatory for us towards the patients. It's not optional. It's not something nice to have, and it's at the core of everything we do, and this is how we want to achieve clinical excellence. You may ask yourself, why patient safety? Well, in minimally invasive cardiovascular procedures, you may use devices such as catheters, guide wires, and balloons. And what you can see here in the picture is the tip of catheter in a beating heart injecting contrast agent. I also brought with me some of these devices so you can actually see how does it look like. So please distribute it around. So I have. Yes. And what you can see here, we have catheters, we have guide wires and balloons. And these ones are used oh, okay. Yes. And these ones are used in such procedures. Now, what do you need to be able to make and to create a quality medical-grade software? Well, first of all, you need to have a quality management system where you plan and control your quality, when you when you manage your processes, and also you measure the performance on the system. But you also have to have something for getting the continuous improvement and getting the feedback from customers. Nevertheless, when we develop requirements, we try to have requirements that are smart, meaning that is specific, measurable, and achievable. If those requirements are not fulfilled, these quality requirements, then we cannot make it as a requirement, and because we cannot test them. When we introduce requirements, we have to look at how we're gonna test them. Are requirements system-wide or just only for a few components important? When we do other requirements, we effectuate design failure mode and effect analysis. So when we see the defects and how we can actually see what kind of failure modes are coming from those failures, and what kind of risk control measures we have to mitigate those risks that are identified in the failure mode analysis. We also have to fulfill standards, and the standards have also impact over your requirements. For example, in our case, we have the IEC 62304 software classification for medical devices. And when we also change requirements regarding image quality, as you see the X-ray images, we also conduct clinical trials for that one. When we look at our architecture and design, we try to have a modular design, so when you change a component, it does not affect, when you change a component A, it does not affect component B. When we introduce interfaces between components, we try to segregate them on their use cases and using the solid principle for single responsibility. We also model those interfaces so we can formally verify them. We also think about error handling and recovery for faulty situation, what happens when different software exceptions happen, but also graceful degradation, how you actually lose functionality in case of a hardware failure. We have to design for these kind of things because hardware will fail. If we look at our usability and UI, when we develop software, we have to take into consideration that we have to keep the situational awareness of our doctors, because when they operate, they have to focus on the patient. And when we develop also the workflow and the UI elements, we have to be consistent to show the same kind of information in the same manner, but also keeping the situational awareness. Responsiveness of the UI is an important item, because you don't want to have a UI that does not respond or for a long time doesn't give feedback for the users. And especially, you don't want to have an interface when you're going to have in critical situation discussions about, like, a tiny button. When somebody says push the tiny button, do you push the button that is tiny or the button that says it's tiny? So when we come to implementation, we conduct bi-weekly software quality stand-ups when we look at the static code results from tools as Tixtool from TOB and Coverity. We also have coding guidelines where we see how do we name variables and how we create initializers and how we initialize our software. We also facilitate pair programming, because pair programming is an awesome thing, because you can share also knowledge, but you can also do code review in the same time. And we have gated pull requests. So when you push your code to the master branch, you automatically will test it. And that brings to our CI/CD part. Excuse me to drink some water. So that the CI/CD part, we can distinguish CI/CD on two levels: component level and system level. At component level, at every pull request, we run module tests. It's a short duration test, and if they succeed, we can merge with the master. But at night, we run the most extensively tests for memory measurement, for performance, and also for a long duration test. On the system level, however, at every night we collect the baseline of the latest baseline of components, and automatically build them and push them to a selected subset of systems where we run acceptance test and regression test. In the acceptance test, we see if that components integrate well and we didn't break any interfaces. And in the regression test, we're going to check if already existing functionality is not broken. Now, we arrive at the verification validation phase. In the verification phase, we verify that our software does what it actually meant to do based on requirement tags. In the validation phase, we check if the system and our software also does what the user needs, what the user expects, and what the user needs are. An important aspect in this part is the tool validation, because even if we use open source software, third-party software, we need to validate it. So we need to check the quality of that particular library, because if the quality of that library is not OK, then our other product is not OK. And meanwhile, in verification and validation phase, we also create and run reliability measurements for the measuring the mean time between failure, which gives an overview of how robust we are. Our way of working, we use Scale Agile framework with concepts such as agile release trains, program increments, and epics. And also every morning we have the Scrum rituals stand-up where we discuss daily work. So the key takeaways. First of all, if you want to make a medical-grade software, it's a regulated industry, so you need to have a quality management system. If you want to be able to test your requirements, they need to be smart, which means that they are specific, measurable, and attainable. You have to have also risk control measures and failure mode analysis, because you have to identify your failure modes and how do you react on that. You have to design for error handling and graceful degradation, because hardware will break down and how you will respond to that. And you have to have tools for static code analysis and also to measure also memories. But we also need to have pair programming to share the knowledge and also to guarantee quality of your code, doing code reviews. And of course, if you want to have reliable software, you have to build up confidence. And the only way to build up confidence is if you run tests. And to run tests, you need to have a strong CI/CD pipeline. That being said, thank you for your presence and for your attention. I hope you enjoyed it. And if I made you enthusiastic work at the medical domain and work at Philips, you can join us at Philips. Thank you very much.